Today we're going to begin Unit 4. Unit 4 is on factoring polynomials and simplifying polynomial expressions. All of this section, the first section that we're going to do, Lesson 1, Factoring Trinomials, should be review of Algebra 1, but this is one of the topics that my Algebra 2 students always need review of. So that's why I started this chapter with a review topic. We need to make sure that you're very comfortable factoring any trinomial that I give you before we move forward to the more difficult factoring. You're going to always, no matter what, when you have a factoring problem, you're going to factor out the greatest common factor first, or the GCF first. You'll hear me refer to that quite a bit. So if I have a polynomial, and remember a polynomial is just a bunch of monomials added or subtracted from each other into one long strand of terms. So if we have this, what we're going to do first is we're going to ask ourselves, is there a number that will divide into every one of these numbers? We've got 2, 4, 10, and 20. Well, 2 goes into all those numbers. So I know the GCF between those numbers is going to be 2. So I'm going to be able to take a 2 out. And then I need to look at the variables. I'm allowed to take out any variables that they have in common. So if your variables have exponents, you're going to take out the smallest exponent that they all have in common. Now, if you look at this, all of them have at least one x. So this has 3 of them, x cubed. This one has 1, this has 2 x's, and this has 3 x's. So the least number of x's that we have in a term is x. So we're allowed to take 1x out of every one of those terms to simplify the polynomial. And then if you look at the y's, we've got a y squared, y cubed, y to the 4th, y to the 5th. The smallest power of the y's is a 2, y squared. So we know we can take a y squared out of each of those terms. And then when I do that, I'm going to kind of just, it is the reverse of the distributive property, but basically what I'm going to do is I'm going to take this common factor and I'm going to divide it into each of these terms separately. And what goes inside the parentheses is what's left in each of those little divisions. So if I divide 2x cubed y squared by 2xy squared, the 2's cancel, leaving me with a 1. And then x cubed divided by x is x squared. Y squared divided by y squared cancels. So the only thing I have left in the first term is x squared. That was a plus, so we keep the plus. 4 divided by 2 is 2. X divided by x cancels. Y cubed divided by y squared is y. Here, minus, we keep the minus. 10 divided by 2 is 5. X squared divided by x is x. Y to the 4th divided by y squared is y squared. 20 divided by 2 is 10. X cubed divided by x is x squared. Y to the 5th divided by y squared is y cubed. Hopefully you remember your rules for dividing monomials from your Algebra 1. Here we're going to review FOIL before we talk about factoring trinomials, because you have to understand how FOIL works to understand why factoring trinomials works. So let's just review that real quick. FOIL, remember, stood for first, outside, inside, last. And that's the method that we use when we're multiplying two binomials together. Remember, a binomial is when you have two monomials added or subtracted from each other. So this monomial is x, this monomial is 6. We put those x plus 6 together, we've got a binomial, x plus 6. Same thing here, this is a binomial, x minus 2. So if I'm going to multiply those two binomials together, I have to use FOIL. And to use FOIL, basically what I'm going to do is I'm going to multiply the first two terms together. If you look at this term, or this binomial and this binomial as two separate things, we're going to multiply the two first things in each of those separate binomials. So x times x is x squared. Then the O stands for outside. If you look at this entire problem as one big problem, we're going to multiply the outside terms together. So the two outside terms are this x and the minus 2. So if I multiply x times negative 2, I get minus 2x. The next term is the inside terms multiplied together. If I take this as one long math problem, the two terms that are on the inside are 6 and x. So 6 times x is a plus 6x. And then the L stands for the last terms. If we take these as two separate binomials, the last thing in each of those terms is 6 times negative 2 is a minus 12. And then the last thing we do with FOIL is we add the like terms together. So we've got x squared, negative 2x plus 6x is 4x, and minus 12. So we have multiplied those two binomials together and ended up with a trinomial. Now, factoring trinomials is the exact opposite of this. Okay, so if you look at what we've got here, x squared plus 4x minus 12. I'm going to take that now and I'm going to go backwards. I'm going to show you how to factor something that we have FOILed so that you know how these two things work together. Right? So if you look at this, we know when we factor this trinomial, we're going to have two binomials. Well, we know that the term that's here and the term that is here, they have to multiply together to give me x squared. Well, if I need two things that multiply together to give me x squared, and my first term is x squared, wouldn't it make sense that if I just take the square root of that, I'll have an x and an x. Now, they're not all this simple, but when you have an x squared here or a variable squared here and the coefficient is 1, it will be that simple. You will take the square root of that and you'll put it right here. Okay? Then the 12 is the number we need to pay attention to. Now, I always tell my students that when you're factoring trinomials, what you're going to have to do is you're going to have to multiply the first and the last term together. But if the first term is a 1, really we can skip that step because 1 times anything is just itself. So in a trinomial where your coefficient of the x squared term is 1, what you're going to do is you're going to take the last term, 12, and then I'm going to ask myself, I'm going to find factors of 12 that can subtract to give me 4. Okay, see how I did that? This number, factors of 12, that subtract whatever the sign is, that's what we're going to do. So if this had been a plus, we would say what factors of 12 would add. But now this is a minus. So what factors of 12 subtract to give me 4? Well, if you think about that, 12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. So which of those factors subtract to give you 4? That's 6 and 2. So, since 6 and 2 are the factors of 12 that will subtract to give me 4, and my coefficient of the x squared term was 1, those are the two numbers I'm going to put here, 6 and 2. Then I have to decide, well, what are my signs here? Okay, now, if you think about it, my x times x is x squared, that's what I need. My 6 times 2 is 12, that's what I need. I need to determine what signs go in these to make this a positive or a plus 4x, okay? Well, in order to do that, what you have to do is look at this sign. If this sign is a minus, that will automatically tell me that these two signs have to be opposites. One's going to be plus, one's going to be minus. If this sign were a plus, they would be the same, okay? So we've got a minus, so we know they're going to be different. Now, if we know these signs have to be different, then if you look at this sign here in the middle, the plus sign, that plus sign has to go with the largest number that I have down here when I multiply my outside and my inside terms, okay? Well, when I do that, if I multiply the outside, I've got 2x. When I multiply the inside, I've got 6x. So the biggest of those is 6x. So the 6x is the one that gets the plus because it's bigger, and the one that gets the minus is the 2. And if you FOIL the outside and inside, x times negative 2 is negative 2x plus 6x. 6x minus 2x is 4x, which is what we started with. I always encourage my students to check what they get to make sure that they put the signs in there correctly. You'll get used to it as you go, but we really want to get very, very quick with factoring trinomials, okay? The quicker you are with factoring trinomials, the easier your standardized tests are going to be, the easier it's going to be for you to move on into the higher level math courses. So here I have 4 more factoring trinomial problems. And if you look at this one has a coefficient of 1. This one has a coefficient of 5, so that's going to require a little bit more work. So we'll have to look and see what we're going to do. Now, when you're factoring trinomials, the first thing you always want to look for is there anything that will factor out of all of the terms? If there's something that will factor out of all the terms, then you need to factor out the GCF first. If you forget to do that, you can get the same answer, but you might forget to take the GCF out at the end, and you might get some points taken off because you forgot that one little thing. So it's always best to do that first. So if I look at this one, there is no common factor between the three terms. So there's nothing I can take out of the whole thing. So in this one, that's just a regular factoring of trinomials. I'm going to do my two sets. So looking at this one, if we look to see if there's anything that comes out of the whole thing, this is a 1x squared plus 8x plus 7. There are no factors that come out of the whole thing. So I'm not going to be able to take out GCF. So I'm just going to set this one up. I'm going to set up my two sets of parentheses for my two binomials. And then I'm going to look at the first term. Since the coefficient is 1, we know that we just take the square root of this term to get what goes in the first part of each binomial. So the square root of x squared is just x. X times x is x squared. Then we need to look at, well, 1 times 7 is 7. Remember, the 1 really isn't going to affect that. So we're looking at factors of 7 that add to give you 8. Look at that again. Factors of 7 that add to give you 8. Well, if you think about factors of 7, there are really only two of them, 7 and 1. Do 7 and 1 add to give you 8? They do. So we're going to put 7 here and 1 here. And then we have to determine what the signs are going to be. Now remember, in the last example, we said that if this number is a minus, these two signs are different. But this sign is a plus. If this sign is a plus, then these two signs are going to be the same. And how do we determine that sign? It's going to be the same as what the first sign is in the original trinomial. So this plus tells me these are the same, and they're the same as this sign. So they're both going to be pluses. And so then we can check our answer. X times x is x squared. The outside term, x times 1 is 1x. 7 times x for the inside terms is 7x. So 1x plus 7x is 8x. And then 7 times 1 is 7. It would also be really wise if you would get to the point where you can go from here to here when you're multiplying FOIL. It's really important to get that mentally and to get that quickly. That will save you a lot of time in the long run. This is something we do all the time in Algebra 2. If you could practice that to the point where it comes natural, that's going to really help you in the future. All right, so let's look at this one. If I look at those terms, it looks like they all have in common, they're all even numbers, right? So it looks like I can take a 2 out of the whole thing. So I'm going to take a 2 out first. So if I take out the 2, 2 divided by 2 is 1, so I have n squared minus 11n plus 10. Now I have a 2 on the outside. That will come down as part of my answer. And then I'm going to factor this trinomial if it's possible to factor it. Well, so we need to look at it. I'm going to bring down the 2. I'm going to set up my 2 parentheses for my binomials. Are there factors of 10 that add to give you 11? Yes, 10 and 1. So 10 and 1 are my factors. This plus tells me that these two signs have to be the same, and they're going to be the same as this sign right here, which is a minus. And then I could FOIL and see if that's what I end up with. N times n is n squared. N times negative 1 is negative 1n. Negative 10 times n is negative 10n. So negative 10n minus 1n is negative 11n. And negative 10 times negative 1 is positive 10. So we know that trinomial works. And then I could multiply by 2 to get what I originally started with. In this one, do they have anything in common? Well, it looks like a 5 comes out of all of those. So I'm going to take the 5 out first. And then I'm looking for factors of 90 that subtract to give me 1. Factors of 90 that subtract to give me 1. Well, if you think about factors of 90, I've got 1 and 90, 2 and 45, 3 and 30, let's see, 5 and 18, 6 and 15, 9 and 10. So think about that. Of those factors that I mentioned, 9 and 10 will subtract to give me 1. So I can use 9 and 10 as my factors. I'm going to bring the 5 down. I'm going to write our 2 sets of parentheses for my binomials. The square root of m squared is m. Factors of 90 that subtract to give me 1 are 9 and 10. This minus tells me these signs are different, and the plus goes with the bigger number. So it's plus 10 minus 90, and I'll let you check that on your own. Looking at the next one. What comes out of all 3 of those terms? I'm looking at it and I'm seeing that a 3 comes out. Is there anything else that comes out? Hopefully you're saying x comes out of that. So I can bring out of that a 3x. When I do that, I have x squared plus 2x minus 6. So my 3x is going to come down as part of my answer. Make sure you always bring that down. Don't drop it. It is part of the answer. It's very important that it stays there. And then factors of 6 that subtract to give me 2. Well, the x can come down. X times x is x squared. Factors of 6 that subtract to give me 2. Well, we've got, let me write those out. 6 is 1 and 6, and 2 and 3. When I factor this one, I could factor out the 3x, but then my trinomial there doesn't do anything else. Okay, I can't factor that trinomial based on what I've got. So this would be the answer. Okay, now be really careful there. I have a lot of students that, because the trinomial won't factor, they want to put prime, okay? That's not prime. Because something factored out, that 3x did factor out, it's not prime. It has an answer, 3x times x squared plus 2x minus 6. It's only going to be prime if nothing came out at all, okay? So you can't say that that one's prime. You do have an answer for that because something came out. As long as anything at all comes out, you're never going to put prime. I have 4 problems here. I want you to pause the video and see if you can solve these on your own, and then I'll come back and explain them, make sure you're understanding what you're doing. Here's one more that I want to point out that you'll see sometimes, and there's a common mistake with a problem like this, so I want to make sure I point this out to you. If we were to try to factor this, we're looking for factors of 10 that will subtract to give you 7. Well, if you think about factors of 10, we've got 1 and 10, 2 and 5. A common mistake for this one is people will look and they'll say, oh, 2 and 5, that makes 7. And they'll put x and x, a 2 and a 5, and then they'll go to put the signs in and put a plus and a minus because the 5's bigger. Now think about what you've just done there. If I FOIL, x times 5 is 5x, minus 2x is 3x, not 7x. See, there's a reason we ask ourselves what factors of 10 subtract to give us 7. It's telling us what needs to happen in order to get that middle number. If we ignore that method and we don't do that, it's very easy to get the wrong answer for something like this. Think about it. Are there factors of 10 that subtract to give you 7? There aren't. We can only add to get 7. We can't subtract to get 7 here. So you have to be really careful. Unless that operation is the one you're using, then it's not factorable. This one we would say is prime because there are no factors that will make that happen.